All right. Hi YouTube. If you're tuning in now, I forgot to record the first like 5 minutes of this. All we did right now is we pasted a example NFT contract into the Flow Playground, and we're looking here, and we're looking at what the potential problems might be if we want to basically have our NFT minter give minting capabilities to other people. If example in this case, we have a resource that gets saved to the account storage here, and there's a function inside the NFT minter resource that allows them to create other NFT minters. So we're trying to see how this original NFT minter would give the newly created minter resources to other people, and that's where we're at right now. So yeah, so we have this in our transaction. We're borrowing the example NFT minter, and then what we're gonna do is say let new minter be minter.create minter, right? And now what do we have to do, right? And well, actually, I kind of already asked this question, but Ricardo and Newman answered, is we need double signers here. Now, the reason we need a double signer is because we need to save this new minter, right? This has a type of example NFT .nft minter. This needs to get saved to another's account, and you can't save it to an account unless you have their auth account. So we need to say signer2.save and move the new minter into their storage at this path, right? And this is good, but there's kind of a problem with this. One, that's really obvious is that you need two signers, and usually that's not a good thing. If you've reached a point where you're sort of like double signing transactions, your architecture is probably not the best it could be, and I would suggest changing it around. And that's what we're going to spend today on. The reason for that is because it's really hard to coordinate double signers. Yeah, exactly, Fabricio. Like multi-sign transactions, it's really hard to coordinate multi-sign. I believe on the Flow blockchain, you only have about like 8 to 10 minutes to get someone else to sign the same transaction that you're signing. Um, and especially in this case, it's really difficult. Um, so yeah, it's not really the best thing. There are ways around this. For example, well, not really ways around this, but there's sometimes where multi-signing transactions isn't that bad. One of them is Emerald ID, actually. So if you go to the Emerald ID website, um, when you go to create an ID, this is actually this is a multi-sign transaction. One of them is being signed by the user who's creating their ID, and the second signature is actually the admin behind all this that's making sure that you actually logged in with your Discord ID and that you're not passing in someone else's Discord ID to map your address and their ID. So this is a good example of multi-signing, but back to my original point, I would mostly try to avoid double signing transactions because it's really hard to coordinate two people's signatures in 10 minutes. And it's also like just technically, hard in code. So if we were to scroll down here, yeah, okay. And the second problem, actually, I'll ask all of you. I'll make this sort of see if any of you can guess it. What is sort of the other problem here, right? Let's say that I at some point wanted to, I'm the original minter, and I wanted to give Numini the ability to mint my NFTs, right? And then 10 days down the road, I'm like, you know what? I no longer want Numini to mint my NFTs. Is that possible in this case for me to revoke that in the future? No, it's not. Exactly, it's not possible. And the reason it's not possible is because, you gave them, the resource. And so that's a really bad thing, right? Especially not that Numini would ever do this. Numini is amazing. But if Numini were to ever in the future become malicious and a really bad person, I'd be screwed, right? Because Numini can forever mint my NFTs. So that's another big problem with just giving someone a resource is, given the resource oriented model of Cadence, they own it, right? You have no ownership over that in the future. So that's a big problem. So anyways, we finally ended up on private capabilities, and that's where private capabilities come in. You can imagine that, what if instead I had the NFT minter inside of my account and I gave Numini a key to my minter. And then at any point, I was like, oh, you know what? Is Numini malicious? yes, I'm going to revoke this path then, and Numini can no longer mint. So it's much safer this way. So let's look at how that's done. So what we're going to do first, actually, there's multiple steps to this, so stick with me here. What we're going to do is we're going to get rid of this. So we don't want the minter to be able to create new minters, but what we're going to do is make a new resource called minter proxy. And this is going to be confusing at first, but just stick with me. This is going to be a minter capability, or just call it minter cap. And this is going to have a type, a capability, that is a reference to an NFT minter, right? And when we initialize this, we're going to say, self.minter cap. And actually, at first, we're going to set it to nil, and I'll show you why in a second here. We're going to make a function to create a minter proxy. And what this is going to do is return a minter proxy resource. All right. Minter proxy. I know I'm writing a lot, but I kind of have to write all this out in order for it to make sense. And then I'm going to make a function to deposit a capability. And we're going to pass in capability here and say self.minterCap equals cap. Okay. So what the heck just happened? Well, what happened is we kept this the same, right? So the original NFT minter has a, it's the resource is getting saved to the deployer, and they can mint NFTs. Now, what we also did is we created another resource called Minter Proxy that's sort of going to be the middleman between the minter and actually minting the NFTs, okay? And we made a function to create a minter proxy. So anyone can create a minter proxy. Now you may be thinking, well, that's really weird. Why are you allowing everyone to be able to create a minter proxy? Well, it's because a minter proxy on its own doesn't do anything. If you look at this, right, this minter proxy has a variable called minter capability, and it's a optional type. So either it can be a capability or it can be nil. And we're initializing it to nil. So if someone, if I were to call this minter proxy resource, right, or this function, get a minter proxy and store it in my account, would I be able to do anything with this? What do people think? Would this? Yeah, no, right? Not at all. It wouldn't let me do anything. But yeah, exactly. But what we can do is we can have this function called deposit capability that will let this minter, whoever has this minter, they can create a private capability, which again is like a key, pass that key in here, and it'll set this to an actual capability that exists, right? And now what this person will be able to do is say, okay, I have my minter proxy. I'm going to do minter proxy dot minter capability. I'm going to borrow this capability. It'll give me an actual NFT minter reference, and then I can call mint NFTs. Is that making sense to people? How this is sort of like almost like a middleman between minting and the actual admin? What do people think? And let me just make sure that I did this correctly. So far, so good? Okay, cool. Now, one other thing I forgot to do here. To allow the admin to actually use this function, deposit capability. What is the person who has the proxy? What are they gonna have to do to allow the admin to actually call this function? Anyone know? Because think about it, right? Is the admin gonna be able to call this function right now, or do we have to link something to the public? Do we have to expose this function maybe to the public? Think so, right? So let's go ahead and do that. Pub resource interface, minter proxy public, and this is going to make this function public. So anyone can call this function. Follow logic but not coding. That's okay. I think the logic is the most important part, because once all this is done, we're gonna go back and actually look at the coding part. So before I move on, do people understand why I had to add this interface here? Because otherwise, right, the admin has no access to be able to call this function on someone's account. And I guess technically, like someone could have just linked their entire Minter proxy to the public, but if they did that, then anyone would be able to access this function, and obviously that's not good. So any questions so far? Okay, I don't think we have any questions. But before we move on, and it's okay if you keep asking questions in the chat, before we move on, based on what we learned on Monday, right? What is the potential problem with linking this to the public? Like I'm referring to specifically what we learned on Monday and with capabilities. What's a problem with this being public, really? What could happen here? Unlink, that's true. But that's not really a problem in the sense that it's okay if the original minter unlinks this because that's a good thing, right? That means that they no longer wanted us to be able to mint, and that's fine. But there is an actual problem with allowing the entire public to pass in a capability. Because what can that capability be? Is it guaranteed that it's valid? No, not at all. Remember, we talked about the fact that capabilities can be completely invalid, but you can still create them. So what do we have to do? Yeah, exactly. You can provide a completely, as Ricardo says, bogus capability. And it works, right? Of course, it won't work when you go to borrow it eventually. Then it will break, right? But you can definitely pass in a broken capability. So what do we have to do here in order to make sure this capability is valid? What function can we call that we learned on Monday? Assert. Well, we can assert, right? But I was looking for what Fabricio says is check. We can use .check, make sure the capability is valid. So you could do that in two places. You could check that here, but with these kind of checks, I just like to put them in the interface. So I'll put them in the interface and say, you know what? As a precondition, we're gonna say that minter capability or minter cap.check. And if that is false, say, sorry, this is not a valid capability. Now, just note that this is the exact same thing as doing this, right? Same exact thing, but I think it's a little cleaner if we just put it in the interface for some reason. I don't know. It's honestly, to be honest with you, I couldn't provide a reason why you would do either or. It's just a whatever you want. So I'll put it here. And the reason I'll put it here is, I guess, the reason I do it this way is just because if someone else in their own code, let's say for some random reason, someone makes their own project, their own Cadence contract, and they want to use this interface for some reason for my contract, they can still get that, check on their code, and they don't have to write it in their own function. So um, I just put it in the interface. So what is it going to check? Yeah, what it's going to check is to see that this capability is actually a valid one. Because as we learned on Monday, users can create capabilities that are completely invalid, but they're still the same type. So this will make sure that this is actually a reference to an NFT minter. All right, so let's go ahead and deploy this contract. Cool. And what we want to do now is we want to have a signer here that sets up the minter proxy capability. So we're going to say signer.save example NFT.create minter proxy, and we're going to store it to /storage/minter proxy. And then what do we have to do after this? Once we save it, what's one more thing we have to do to make sure that the admin can actually deposit? Yeah, link it. Exactly. So signer.link example NFT dot NFT minter restricted to example NFT dot minter. Oh no, sorry. minter proxy, and then minter proxy public. Oops, I can't type for my life today. Minter proxy public, and we're just going to store this to /public/minter proxy. This annoying error out of the way, and then the target is this. Alrighty. We're cool, right? We cool. So let's call this setup minter proxy. All right, let's go ahead and run this with account 5. Random account, but account 5. Send it. And we set it up. Cool. We just did that. Now let's make another transaction to mint NFTs. And let's see, just to confirm, even though we all know this, let's just confirm that this is not going to work, right? Let's just do that. So mint NFTs, let's copy the transaction. This is the same signer that has the minter proxy. So we're going to say let minter proxy equals signer.borrow from /storage/minter proxy. And this is going to be a example NFT dot proxy type, just like that. And we're going to try to get the underlying NFT minter reference by saying minter proxy dot minter capability dot borrow. Oh, well, we have to unwrap it first. Dot borrow. And obviously this is going to fail, right? It's going to force panic right here. People think that, right? It's going to force panic here because right now it's nil. It's nil because we set it to nil. So this isn't even going to work. If we even try to run this transaction, it's going to say found nil while forcing an optional value because of this right here, because that's nil. So we can't even do as much as borrowing the underlying reference, right? And just to further clarify what this is supposed to be an NFT minter reference, but yeah. Okay, so that doesn't work. So we have to make a transaction to deposit minter cap, right? Deposit minter cap. Now what we have to do is, so this is going to get signed by the original NFT minter. Okay. So we want to basically create a capability to an NFT minter and then, fetch the public minter proxy and then deposit it to this user, right? But this is where private capabilities come in, is we want this capability to be private, because if we made it public, then anyone would be able to just borrow the NFT minter. But if it's private, then we can use it as a key. So let's go ahead and do that. So signer.link example NFT.NFT minter to /private/NFT minter, and the target is the storage path, as all capabilities are, just like that. And then now that we have linked this to the private path, we can actually get the capability. So let private cap equals signer.borrow or signer.get capability from /private/NFT minter dot borrow type. Okay. And we don't have to put a panic here because, well, we pretty much can confirm that it exists. We literally just made it here. And then we can say, now that we have this private capability, remember this is a capability that is a example NFT.NFT minter type. Should be. Should. Oh, you're right. I am a total idiot. I'm a total idiot. We shouldn't have borrowed this, right? Yeah. See what I did wrong? I borrowed it, and obviously you don't want to. If we want a capability type, right? If we want a capability type, you shouldn't borrow it. So I am an idiot. So we will simply get the capability like this, right? Cool. Now that we have this key or this private capability that we want to pass around, we need to actually fetch the public minter proxy, call this function. So let's do that. So let and we need to have a recipient here that is going to be receiving this. Let recipient proxy equals get account recipient dot get capability slash public slash minter proxy dot borrow an example NFT dot minter proxy that's restricted to example NFT dot minter proxy public, right? And so we'll panic if it says, hold up, the recipient has not set up a minter proxy. Then we can say recipient proxy dot deposit and pass in the private cap. Wow. Using. But sort of makes sense if you stare at it long enough. So Fabricio says we need bit confusing for now, yes. Yeah, I know. It can be a lot, yeah. Fabricio says we need to check if exists before borrow. We need to check if exists before bar. Oh, do you mean this one? Or this one? Blurry? Okay, let me zoom in. How's that? Better? Okay, cool. Oh, I think you mean this one, right? So yes, you're definitely right, Fabricio. We can check to make sure this one exists. Although the reason that I didn't do that, yeah, you're totally right. We could end assert here this is private capability dot check, and then the message could be like, doesn't exist. The reason you don't really have to do this though is because we pretty much know this exists because we like literally just linked it right here. So it's not too necessary, but you're right. We could definitely have this here if we wanted to. But yeah, again, because we like literally just linked it here, like this must exist. All right, so recipient. Oh yeah, so okay, so the signer, right, is the admin, the original minter. So the signer is account 1, and the recipient is account 5 because account 5 is the one that set up the minter proxy. So if we send this, all right, went through, and if we go back to minting NFTs, we should be able to actually mint NFTs now. So let NFT be NFT minter ref dot mint NFT, and then we can just like log nft.id and destroy it after. Try it. And we're setting this with account 5 now. Boom, it works. Pretty cool, right? Boom. So now this account can mint. Awesome, right? Now let's say 10 days have gone by and I'm like, you know what? Account 5, you're pretty sus. Um I don't want you to mint my NFTs anymore because you've been minting too many and you're not a nice person. What would I do? It would just require one line of code. Yeah. Unlink private cat. And all you would do is in here, you would also sign this by the original minter. Literally all you would do is just say signer dot unlink private NFT minter. And if you unlink your private minter, let's send this by account 1. If you unlink your private minter, now account 5 can no longer mint. So there you go. There you go. Access control made easy in Cadence. Now, let me throw another problem at you to sort of make this a little more complicated. Yeah, true, right, Ricardo? Yeah. Yeah, done simply by a proxy resource, public capability, a private capability, and 5 different transactions. Um, But let me throw another problem at you. What if I gave away a bunch of private capabilities, right? I was like, you know what, Ricardo, you can mint my NFTs. Numini, you can mint my NFTs. Falcon, you can mint my NFTs. And then I'm like, you know what? I just want to take away Falcons. What's the problem with this current setup? Yeah, I'm taking yours away, Falcon. You've been bad. Yes, Ricardo. Yep. Well, you're creating it in the admin account, but you're storing the capability in people's proxies. Yeah. Yeah. So Numini got it right. Yeah, Numini got it. So the issue is that even if I just want to take away one person's, when you unlink this private capability, it takes it away for everybody, right? Not great. Can anyone think of a solution? What's a pretty easy solution actually? Boom, BZ. Nice. BZ got it. So you store it in different paths. So when I go to give someone a Minter proxy, right, I'll link it to NFT Minter W Falcon, right? Give this one to Falcon. Then I want to give one to BZ, NFT Minter BZ. Give this one to BZ. Now I want to give one to Amethyst. Give one to Amethyst, right? And then when I'm like, you know what? I just want to take away our Falcons. I go here and I take away W Falcon, but everyone else can still link, or everyone else can still mint. So that's the solution to that problem. So what are we thinking about private capabilities? Confusing? And also, just for the record, this is like probably one of the more confusing use cases of private capabilities. There's a lot of other use cases for them. And actually, BZ, do you mind sending me the Flow view source link to the Beast market? Should you use a collection of private capabilities? What do you mean by that? Remembering each path. Oh, you could do that. Yeah, yeah, yeah. You could definitely track it. Yeah, yeah, yeah. I think what you're getting at is like there's a much better way to track it than to just like hard code it and then hope to God you remember it in the future. There's definitely better ways. Maybe you could use a collection resource, or maybe you could use a function. I think can you create? Actually, let's go to the. This is a good time to test this. But can you create paths from strings? Wait, let me try this out. Oh, you can. Yeah, you can. Yeah. So what you can do actually then, kind of like Numini was suggesting, is you create private path and you pass in like an address, right? And what you can do is, sorry, what you can do is return a private path where the identifier is the person's address. Why does this not work? Oh. So you can make a function called create private path, and you can do something like, NFT or minter proxy dot concat this. And what this will end up looking like is it'll create a private path that looks like slash private slash minter proxy OXO1 or OXO2 or 3, whatever you pass in for this 4 address, right? And then at some point in the future, when you want to take away the private capability, you would just pass in, who you want to take it away from, and then it would give you that private path, and then you would unlink that private path. Does that make sense? Yeah. This is probably the best way to do that. So BC says poop also has minter proxies. I didn't know what it was for because Kai has, but now oh yeah, there you go. Oh, okay, great. So BC has no idea what he's coding. That's so funny. So, like I was saying, this is definitely on the more complicated side of when you would use a private capability. Proxies are sort of their own concept, right? When you're talking about admin rights and minting capabilities and all that. A more common, and I would say a more, yeah, or at least an easier example, is marketplaces. So we're currently looking at the Basic Beast marketplace contract. And this looks very similar to NBA Top Shot. So if you were to pull that up, you would see pretty much the same exact thing. Um, Look at this one right here. So this one that I'm highlighting is clearly a public capability because it's a public receiver to a FUSD vault. So that's most likely coming from the public path. However, this one better be coming from the private path, right? Because you would never want to expose your entire Basic Beast collection, or Top Shot or whatever it is. So this is a private capability, and what happens here is when the user creates their sale collection, they link a private capability to their collection. They pass it in here, and that way, when a purchase is made in this purchase function, if you were to scroll down, it says self.owner collection, which is a private capability, right? Dot withdraw. So the reason, again, you have to use a private capability here is because you obviously couldn't pass in a public capability because then this contract would not have the ability to call that withdraw function right here when a sale is made. So there you go. That's probably a more common and easier example, but I think it's cool to check out. All right. So that's it for private capabilities. Are we ready? Are our brains prepared for talking about poor capability links? Or do we want to postpone this till the next session? Let's do it. All right. Poor isn't cheap. Not cheap. Poor as in you're a trash developer. Um, so this one's not going to talk about. We're not going to be coding that much in this one. It's more just stuff I want to throw at you. Um, I'm trying to think about how I want to really teach this one. Let me actually. Yeah, I mean, this is going to be a little bit of reading, I think, because there's not really much I can code. So thinking, thinking. All right, let's take the. Wait, it's the one that has the mistake in it. Check. Yes, it does. Perfect. So what we're going to be doing for the next 15 minutes is talking about mistakes that the Flow and Dapper team make all the time, and why we shouldn't do that because we're better developers than them. Let's go ahead and also deploy non-fungible token. And of course, because the playground isn't updated, even though I've begged them 10 times, I get rid of this. And of course, play this contract, right? And then let's go ahead. By the way, is it still blurry if I do this? It is blurry. Aw. Okay, one sec. I'll put it back to the non-blurry one in a second, but I'm just trying to delete a bunch of random stuff here. Metadata views, man. They're amazing. They also can be a big cow. Lots to delete. Wish I had prepared this. Sorry, everyone. Stuff. Almost there, I promise. What am I doing wrong here? Yeah, so true, Ricardo. This is the this is the adventure that you all are willingly embarking upon, so I guess I can blame no one but you. Um, does not conform to resource interface collection public? Why? Raw deposit, get ID. Okay, well, the playground is, as you can see, very fun to work with. Um, by the way, the problem the reason why I hate sometimes the metadata views is because when you go to deploy this on the, I'll show you, when you go to deploy this on the playground, right? First of all, you have to copy all this code, which is like fine, right? It's like whatever, you copy it in here. And then it's like you have to go to the top and you have to also import non-fungible token, which again, I have literally begged them to please just deploy this automatically, but I don't know why that's not a thing. So you then have to go and deploy non-fungible token, right? So then let's go and deploy that one. But of course, the playground's never up to date, so then you have to delete the code that's not working in the current version. So you go and do that, and then it's like, okay, nice, I finally got non-fungible token. But you also need metadata views, so you go to get metadata views, and then you think you're finally safe, but you have to copy 3,000 lines of code. So once you go ahead and copy an entire dictionary, you're like, oh wait, maybe I'm finally saved. And then you're like, wait, no, because I also have to deploy fungible token. So you go to deploy fungible token, and finally, after 4 hours, you have reached your destination. And let's deploy that. And then we can finally deploy this one. And then we can finally deploy this one.
That's so funny, actually.
Oh wait, but you can't because there's still a problem. Wait, what's the problem though? That collection public? Don't joke, that would literally take me 4 hours. I know. I still can't even figure out what the problem is. Is it because of borrow NFT safe? Is that why? Oh, so there's just a full-on error too. That's awesome. All right, let's just get rid of this because whatever. Redeploy this one. Oh, I have to. Oh, I have to redeploy all these too. Yay! Woohoo! Playground. Okay, wait, is it done? Yes, we did it. Round of applause in the chat. We deployed the standard contracts. Yes. Um. So what was I even trying to teach? I don't even remember at this point. Oh yeah. Okay. So we're gonna talk about setting up accounts. Set up accounts. Someone should tag. Oh, yeah. I mean, the truth is, I've given the Flow team so much crap this month that honestly, I'm not gonna keep bugging them because I know they're trying their best and they're great people and they are trying. So yeah, I was what this whole day, which we're gonna have to talk about this next time, but I'll intro it to you today. Is port capability links, and this is really talking about how you set up accounts on Flow. Um, so let's do that. So when you set up an account, of course the playground's like just shoving errors in my face now. So you do signer, dot save example NFT dot create empty collection, and let's see what's going on. Look at this. Look how interactive this is. Wow. Oh, really? Something went wrong? I can't tell by the 100 errors that's being thrown at my face. Common playground L, so true. And the worst part, wait, watch this. If I refresh the page, is all my progress going to be lost? Let's see. I can't wait to find this out. Oh, wait, it broke. Wait. Oh, it broke. Oh, yay, we have Max here now to to see our pain. Hey, Max. This is the live example of why the playground is not very user friendly, I guess. Oh my god. Honestly, for all the times I've joked with the playground, I actually think this is the worst it's ever been, right? Have we reached a new Yeah, is my whole computer broken? Am I hacked? If this is the Beast contract, I'm gonna kill you, BC. Oh, okay. Oh, we're back. Okay, we're back. All right, so let's continue where we left off. Let's do signer.save example nft.create empty collection. And if we go here, we're going to save it to /storage/nft collection. All right, cool. Now, we need to link this, right? And the normal way to link this um, is to put example nft dot collection, right? That's the base type. And then all your interfaces. So one of our interfaces is going to be non-fungible token dot collection public. And of course, we have to import this from OXO2. The next one is going to be non-fungible token dot receiver, right? We also have to do the metadata views one, which if we scroll all the way down is metadata views dot resolver collection. Okay, there's another one. Import metadata views from 3. And there's also another one, which is example NFT collection public. Yeah, BZ, I would like to, but I don't even know what the other that is true. But the problem is that running transactions on VS Code is so hard also because it's so manual. And then you save this to /public/whatever /target /storage /whatever. The main point is these, right? This is the correct type you want to link. Is there a better way to view this, by the way? No. Okay. Anyways, this is the right way to link it. Now, yeah, let me try to zoom in. Okay, so you're not gonna be able to see everything, but this is, I guess, kind of the point. Now, the thing with this day is what we're going to talk about is what happens if you just link this, if you get rid of the base type here, or what happens if you think you're a smart guy and you're like, you know what, screw the standards, I'm just going to link my personal one, because this exports the same functions as the NFT standard, but so I don't need to export I don't need to link my non-fungible token ones too. Because if you go here, what a lot of people think is, oh, my example NFT collection public, which I don't know why they named it this long, but this interface exposes deposit, get IDs, borrow NFT, and borrow example NFT. So why would I ever need to also link receiver, deposit, and these three? Because again, they already exist on my interface. To which I'd be saying, no, you should be banned from coding ever again your entire life. So we're gonna put these back. Now the reason for that, and I remember I said there's gonna be a lot of reading here, so I'm sorry. But the reason for that is because scroll up a bit. Yeah, wait. Yeah. This is under the forgetting an interface section. So it's very common that developers only link the NFT contract's custom interface, like I'm showing you here, right? Instead of also linking the non-fungible token interfaces like so, right? This is bad because although it may be true that the collection public interface includes all the same functions, as I just showed you, right? This has the deposit, the get IDs, all that. Um, that does not mean you should not link the non-fungible token interfaces. Now, the reason for this is because when other dApps or marketplaces are trying to call into your code, those places or those marketplaces, they don't know anything about your code, right? They're just all they can do is do their best to read into your code and try and get information the way that they know how. Now, the way they know how is through standards like the collection public and the receiver and stuff like that, metadata views.resolver collection. That's how they know how to read your collection. They don't know about your specific interfaces. And so it's really important that you don't forget the standard interfaces because of that fact, because those things will not be able to read your collection. Now, I'll give you an example actually. If we go to the Top Shot, where is Top Shot? Let's look up NBA Top Shot smart contracts. If we were to go here and go to contracts, or no, go to transactions and set up collection, you will notice that they don't link non-fungible token.receiver. And remember, this is the Dapper team themselves. And they don't even link non-fungible token.receiver. So what's the problem with that? Well, anytime that a third-party dApp wants to deposit to a Top Shot collection, they can't because they don't know how to read into it. The only way they would know how is if they, said, okay, instead I have to use collection public, and I guess they could figure that out because at least there's one standard interface there. Or they would have to know about their custom interface, which of course, how would they know about that? They can't. So they would have to go through here. So basically, non-fungible token net receiver is completely useless here, and that's pretty terrible, right? Yep. So that's pretty bad. Now, this also affects things, by the way, like Emerald Bot, because how do you think that Emerald Bot knows about who owns what NFTs? Well, of course, Emerald Bot has no idea about custom interfaces like this. It only knows about the standard ones. And so when it goes to read people's collections, it tries to, do that through the standard interfaces. And if something like non-fungible token collection public isn't linked, then EmeraldBot has no idea that you own certain NFT IDs, even if you link, the custom interface, because again, it doesn't know about that. So that's one thing I wanted to point out. And of course, if you really want to get into this topic, you can read through this. There's a little bit more on that, but long story short, this is the most important line. Always link all the proper interface to the public, even if you don't think you need to. So there you go. Always do it. And again, if you want to know why, have fun reading this text. Now, a little bit more important is this one, and I'll try and go. Do we want to do this now or next time? It's up to you guys because we already reached time. I think maybe we should leave this to the next one because we're gonna go over a mainnet example. So I'm gonna leave this till next time. Just checked my copy pasta is good. Good. Yeah, that looks good to me, BZ. Nice. All right, so that's all I have for all of you today. Yeah. Yeah, good thing you didn't get it from NBA Top Shot, because that would have been bad. Also, the quests for this day are pretty fun, I think, because they basically give you bad links and they try and ask you like how to get to it. It'll be fun if you try it out. But next time we'll pick up on using any resource, and we'll talk about some of the security problems or just inconveniences that come with this. So I'll see you on Monday. Enjoy the rest of your week and have a great weekend. Peace out. Also, I'll put all the recordings in the announcements channel. Bye, everyone. Peace out.